Hello everybody, this is your community pharmacist, and in this video we will be going over a couple of problems that involve sensitivity requirements as well as calculating aliquots. Now personally, aliquots were my least favorite part of compounding, and so today I will show you how I calculate them, which I find to be easier to understand. So let's jump right into question number 1. You can go ahead and pause this and solve it. Otherwise, the question reads, a torsion prescription balance has a sensitivity requirement of 4 milligrams. Explain how you would weigh 25 milligrams of metoprolol tartrate with an error not greater than 5%. Use lactose as the diluent. So, what we'll want to do first is calculate our minimum weighable quantity. We'll do that with this equation. That is 100% times 4 milligrams, which is our sensitivity requirement, divided by 5%, which is the which is the error we have in this problem. So calculate that, and it equals 80 milligrams. I like to go ahead and label this our minimum weighable quantity, just so we know what it is later on. Now, because we need 25 milligrams of metoprolol, and our minimum weighable quantity is 80 milligrams, we'll definitely need to use the aliquot method here. The way I do it is I take the amount we need. Now you can consider this the absolute value of it, which is 25 milligrams, minus our minimum weighable quantity, which is 80 milligrams. So the absolute value of that is 55. Okay, so this is the amount of drug, and this will be the amount of diluent we need in it. But we need to calculate our aliquot. So what I do is I take 80 milligrams and I divide it by 25 to find how many times that goes in there. In this case, it is 3.2. So now sometimes that 3.2, when you multiply it by 55, will not give you a whole number. It'll give you a decimal or a fraction, but in this instance it works out just fine, and that leaves you with 176 milligrams, and over here this leaves you with 80 milligrams. Keep in mind this is your drug and this is your diluent. This right here is our aliquot. So drug, aliquot, diluent. So from here, each 80 milligram aliquot that you take will contain 25 milligrams of metoprolol, as well as 55 milligrams of diluent, which in our case is lactose. And that's it. And now for question 2, go ahead and pause this if you'd like to solve it. The problem reads, a torsion balance has a sensitivity requirement of 6.5 milligrams. Explain how you would weigh 20 milligrams of a substance with an error not greater than 2%. So for this, we'll go ahead and calculate our minimum weighable quantity again. So that is 100% times 6.5 milligrams, which is our sensitivity requirement, and 2%, which is our error. Go ahead and calculate that, and that is 325 milligrams. That is our minimum weighable quantity. So from here, we will take the 20 milligrams that we need to weigh out. And this, by the way, is another aliquot calculation. Subtract it by 325 milligrams, which is the minimum weighable quantity. And that is 305 milligrams. That is your diluent. So 20 into 325 is 16.25. But for our diluent, that would equal 4956.25. I don't like using decimals here because it might be difficult to measure that on a scale. So I go up to the next nearest whole number, and that would be 340 milligrams of drug. Milligrams, not grams, of drug. And this would be 5,185 milligrams of diluent. So this is how much drug you would weigh out. This is how much diluent you'd weigh out. Combine them, titrate until homogeneous, take out your 325 milligram aliquot, and you are left. So 325 milligram aliquot will leave you with 20 milligrams of drug and 305 milligrams of your diluent. On to prescription, or problem rather, number 3. Go ahead and pause if you would like to solve this on your own. The question reads, prepare 10 capsules each to contain 50 milligrams of losartan potassium and 12.5 milligrams of hydrochlorothiazide. Lactose is to be used as a diluent. A prescription balance with a sensitivity of 6 milligrams is available, and a 4% error is acceptable. Provide the relevant calculations. So, let's calculate our minimum weighable quantity. And that is equal to 150 milligrams. So over here in the corner, we need 10 capsules total times 50 milligrams of losartan is 500 milligrams. We're okay with that one. We can weigh that because it is greater than our minimum weighable quantity. Let's check for the hydrochlorothiazide, which is 12.5 milligrams. And we are not okay with that one. 125 milligrams is less than the 150 milligrams of the minimum weighable quantity. We will need to calculate the aliquot. So we need 125 milligrams minus the minimum weighable quantity gives you the diluent. So can't do 2 times the drug, because then 2 times the diluent will be less than the minimum weighable quantity. So for this case, we are going to look for the diluent, which is less than our drug amount, and we'll find something that is both, but this is divisible by that, or a multiple, and multiply it by the same over here. For this, it will be 6. Our factor will be 6, and that equals 150 milligrams of diluent. Over here equals 750 milligrams of hydrochlorothiazide, HCTZ. Remember, this is our aliquot. So every 150 milligrams of aliquot will yield 125 milligrams of hydrochlorothiazide and 25 milligrams of diluent. For the losartan potassium, we will simply need to weigh out 500 milligrams of losartan. And that's problem number 3. And for problem number 4, go ahead and pause the video if you would like to solve it yourself. Otherwise, the question reads, using a 10 milliliter graduate cylinder calibrated in 1 milliliter units, explain how you would measure 1.25 milliliters of a dye solution by the Aliquot method. Use water as the diluent. So we will go ahead and calculate our minimum weighable quantity. So for liquids, for graduated cylinders, we use 20%. So 20% of 10 milliliters gives us 2 milliliters. And that is our minimum weighable quantity. So 1.25 milliliters of the dye minus 2 milliliters total, which is our minimum weighable quantity, equals 0.75 milliliters. Our factor will be 4, which I like to use the smallest factor we can. This leaves you with 5 milliliters of dye and 3 milliliters of diluent. Keep in mind that this is our aliquot. And this is water in this case. So every 2 milliliters of aliquot will have 1.25 milliliters of dye and 0.75 milliliters of water. And that is that for these 4 problems. If you have any questions, please leave them in the comments below, and I will try my hardest to answer them appropriately and in an appropriate amount of time. Hope that helped, and best of luck on the compounding exam.